Welcome, everyone. This is the last episode of my podcast series, Phymaths Podcast Season 1. In this episode, we have two well known physicists, Dr. Pervez Hoodbhoy and Dr. John Bricmont, as guests. And the reason because of which we got these two people as guests is that they have very similar interests apart from being physicists. They talk about political stuff, and we wanted to discuss their political topics with them in this particular episode. And in this episode, I also have a co host whose name is Abdul Afzal, and he will introduce the guests to you.
Oh, thanks for that, Hassan. And I think most of you guys will already be familiar with Dr. Pervez Hoodbhoy, but like for those who don't know, Hoodbhoy is a prominent nuclear physicist in Pakistan. He is his PhD from MIT, and he's written a great book in the 90s called Islam and Science, in which he discusses the challenges like the Muslim Orthodoxy faced like after the Islamic Golden Age and stuff like that. John Brickman, which I think your Pakistani audience might not know, is he's a very famous figure. So he's also a physicist, not a nuclear physicist, but he specialized in statistical mechanics, working mostly in renormalization group. And what he's most famous for is during the science wars in the 90s, he wrote a book called Fashionable Nonsense alongside Alan Sokal, which was very prominent, especially after Sokal's affair, in which he criticizes like a lot of postmodern thinkers for their misuse of scientific language in order to advocate like their whatever political agenda, some sort of political agenda and stuff. Other than that, he's also known for his work on Bohmian mechanics. He's one of the biggest defenders of Bohmian mechanics, and he's written a book called Making Sense of Quantum Mechanics, which is a review and a defense of Bohmian mechanics for anyone who's interested. And we'll link all of the books down in the description below. And
And one more thing that I wanted to add is that,
this is going to come in two parts. The first part is basically dubbed Realism and Quantum Mechanics, in which they discuss like basically what is the fundamental notion of reality? Is there a reality outside of our mind? There's a lot of disagreement there. Then there's a discussion of quantum mechanics and the history of quantum mechanics, and it does get technical at some points, but I would still ask you to like hang on, listen to the talk. I think you'll guys gain some sort of knowledge from it. But if you're not interested, there's also a second part, which is more sociologically oriented than essentially just like deep physics. Hassan can tell you about that.
well, actually, the second part is more about free speech and secularism. So, if anyone is interested in these particular topics and the opinion of these two people on these topics, then we will highly recommend you to watch the second part. And one more thing that you should keep in mind is that this podcast was, recorded on 19th of October.
Yep, and that's all.
So we hope that, we hope that you enjoy the podcast.
Right. Thanks. So welcome to both of you.
Okay.
Welcome. Thank you.
So I will ask the first question. Actually, it's more like a discussion topic on which we can start the discussion. So can I start with Dr. Hoodbhoy? Because actually I will ask a question on which I want the answers of both of you. But I think I want to start from Dr. Hoodbhoy. That both of you, Dr. Hoodbhoy and Dr. Brickmont, both of you are physicists, but you have had the experience of talking about political matters a lot, right? So I have two questions for both of you, and I would like to start with Dr. Hoodbhoy. That what was your motivation for talking about politics? Because there are many physicists who say that we don't want to get into politics and stuff like that. And the second question is that how has that experience been for you? Because as we know that there have been many difficulties for you just because you talk on politics and sensitive issues like that.
Well, it's not that I want to talk about politics, but it's that politics imposes itself upon me in every aspect of life here in Pakistan. So when I came back at the age of 23 to teach at Islamabad University, I found that the chairman of my department had just calculated the speed at which heaven was running away from Earth. He used the theory of relativity to calculate that that speed was 1 centimeter per second less than the speed of light. So I said, my goodness, this is very, very strange. He took a verse out of the Quran, which says that on the night of Laylatul Qadr, that is the night on which the Quran was revealed, as being equal in terms of prayer to 1,000 nights of ordinary prayer. And so he equated that to the gamma factor in relativity and got V over C to be exactly that. Now, when you're faced with such a ridiculous nonsense, then you say, well, okay, I'm going to be teaching physics. And yes, I did teach physics until I retired, and I'm teaching physics beyond that. But there is so much nonsense that goes on in the name of a religion and science that I had virtually no option but to start thinking. And over time, I encountered more and more. In fact, what led me to write my book on Islam and science was this conference. It was called the International Scientific Conference on Miracles of the Holy Quran and Sunnah.
Mm-hmm.
And it was organized by General Ziaul Haq.
Mm-hmm.
Some 200 so-called scientists from Muslim countries had come, and they talked of every kind of nonsense under the sun. So that's when I said, look, I have to get into this seriously. And that's how I started thinking and then talking and writing.
Mm-hmm. Okay. So if I pose this, say, actually this was the first part of the question, that what was your motivation in coming into the political stuff? So if I just throw the same question to Dr. Bricmont, so what was your motivation for doing such kind of activity, such kind of talking?
Well, I appreciate what Pervez has been saying, and I respect enormously the work he's been doing. But I live, of course, in a totally different part of the universe or the world, both geographically and ideologically. So I'm a child rather of 68, and I had also a religious education, but Catholic. And even though there was a lot of nonsense, there was nothing even close to what you are describing. Even the Catholics in my youth were trying to educate me, or didn't succeed very well. They were, very, very conservative. By today's standard, they would be considered ultra conservative. They were applauding the dictatorship in Southern Europe, in Portugal, and so on, and they were, very reactionary in morals, etc. But they accepted evolution. But they would never do the kind of computation that you mentioned. They were not literalist about the Bible or even about the miracles. They were open to miracles, but not forcing everybody to believe in every miracle in the Bible. So compared to the situation in Islamists, as they call it, Islamic, maybe it's Islamic, I don't know, what you describe, they were still very enlightened. So the problem was not like that. But of course, I didn't like that. And then, you see, I was in the 68 generation, which rebellion was against, of course, the relative tyranny of the church and the conservative of the time. But my view of the world changed when I went to the United States as a postdoc in 1978, and after my PhD, which I did in Belgium. And I read Chomsky, and I got more interested in international politics, and particularly the imperialist policies of the United States. And so I became more critical of that. Then I also read Herman and Chomsky about the media, then I became more critical of the media. And when I came back to Europe in about 10 years later, I realized I was very, very marginal, because it was really, my generation has changed so much in the direction of the discourse now of humanitarian, what I call humanitarian imperialism. They were also absolutely, they thought criticizing the press or the media was far right. And then they were also against free speech, because then there was a problem of free speech, which had come in between, where Chomsky has been involved, and I tried to defend Chomsky, and that was impossible. It was even impossible to discuss his theory of mind, and ever since I've been extremely marginal and therefore in a sense like you, but not in such difficult circumstance, but still relative to the democratic idea of our country, I've been in a somewhat difficult position to defend my political views, let's say. But I never had serious I never had problem in my university. I must say that my university is Catholic or used to be Catholic, and I never had problems. But of course, it's also because it used to be. If it remained Catholic the way it was, I would have had problem. But it has become essentially non-Catholic and even anti-Catholic to the point that recently a professor who dared in one course criticize abortion, was kicked out, which I objected to because I object also to that. But it changed so much that it will become impossible to criticize abortion, which to me is a big change because, as I say, when I was a kid or even when I was a student, Catholicism was really a serious matter, even though, as I said, not as anti-scientific as the Muslim or the Islam.
Okay. So, Dr. Hoodbhoy, you wanted to say something?
Yeah, I think Jean and I have one common point of interaction, and that is Noam Chomsky. When I was an undergraduate at MIT, I was deeply influenced by him. I saw him first in anti-Vietnam War protests, but then I took two of his courses, and they were not on linguistics. I wish I had taken the linguistics course also, but they were on the issue of freedom and on the issue of intellectuals and social change. And Chomsky was insisting. He said, look, it's not enough for you to come to a university and learn a technical trade. You've got to think about the world. You've got to think about your place in it, the horrors that are visiting this planet. And he was, of course, in the forefront of the war against Vietnam. And later on, through Iqbal Ahmed, I got to be very good friends with Chomsky. And today, we continue to correspond, although it's more than 50 years later.
Yeah, of course, I did quite a lot. I mean, at least what I could do to have him translated into French and be known in France. He was invited in Paris. I invited him in Brussels twice, or at least I was involved in his invitation to Brussels. But it's very difficult. It's very difficult because of the problem of free speech and the Forisson affair and so on. I don't want to go back to tell, unless you insist, I want to tell back this whole story, but his views were misrepresented and it's still very difficult to discuss, even though he's less demonized than he used to, but in the 80s it was absolutely impossible. Yeah. So, what can I say? I mean, as I say, my situation, now I'm retired, so I do what I want. But another thing, which is, of course, I don't know if we are, we don't have to agree about physics because Abdul will not agree with me. But one thing that was always bothering me, and that may be more because since we're all four of us physicists, is when I was a student, I was studying quantum mechanics, they were telling us that the physics does not deal with the world, but with our knowledge of it. And it never made any sense to me, because if we have a knowledge, then the knowledge about the world. So the sentence is self-contradictory, even though you find it in many quantum mechanics textbooks. And that's something that led me to a more, if you wish, non-political, not only not political, but philosophical and scientific interrogation about quantum mechanics, because I always found it, there was a root, you see, it was one of the roots of a rebirth of idealism. By idealism, I mean, it's all in your, I mean, I simplify, but it's all in your head, you see. The world, what your view of the world is really produced by your brain or by society and something like that, and not by direct influence of the world itself. Now, this is, of course, a long philosophical discussion, which I'm summarizing, but there is an opposition between realist and idealist in philosophy. And quantum mechanics has seemingly given arguments to the idealist. Now, one of the reasons I fight idealism, and that's linked now to Sokal's book, the book with Sokal, which I have discussed these things very often with him, and he agrees with me more or less, is that idealism, of course, well, first of all, it's wrong. We do have knowledge of the world in general, maybe not in quantum mechanics, but in general. And then it also leads to relativism. And that's one of the plague of our time, at least in the West. But of course, it plays also in the hand of the Islamists for reason I will explain in a minute. But the way it works out in the West is that then people say, okay, it's in our head, but there is no universal mind that sort of, construct a representation of the world, but there are different groups, different social groups that are creating their view of the world, and the world doesn't say anything about that. Okay, it's all in our heads, but it's a collective heads. So it's not some, soul or some or God or something. I mean, for Berkeley, for example, God was him, putting ideas in our mind. I mean, there's no outside world, but there was God nevertheless. But here, it has atomized the world into different communities. So you have different views of the world depending on whether you are black or you're a woman, or you are gay or something. You have all these things, and then you have different epistemologies and so on and so forth. And this leads to an extreme confusion whose root, in my view, is idealism. But because if you had a realist view, then there would be something common to everybody. And that, of course, plays in the hand of the Islamists, although the Islamists, of course, are exactly the opposite of relativists. They are absolutists. They're absolutists. The religious people are the exact opposite. Actually, there was a professor in my university who was in anthropology, and he was always, when he was mentioning Sokal and me, he always said that we agree with the Pope. Because the one agreement we had with the Pope is that there are objective truths. The Pope thinks there are objective truths. I think so too. But I am a more empiricist, and of course the Pope is not. But at least the Pope back there, it was in the past, it was John Paul II. But but you see, the absolutists, but they benefit from relativism because relativism destroys the possibility of a rational critique of religion. So they can say, okay, well, we have just a different epistemology, we have different view, etc., etc. And so in the West, I'm not saying in Pakistan, probably that's not the argument, but in the West, or maybe in the more sophisticated parts of, Islamist, they will use relativist argument in order to justify religion, even though their religion, in the end of the day, is absolutist in a way which I am not. Of course, I'm an empiricist, so I think our knowledge is knowledge about the world, but it's revisable, etc., etc. Anyway, that's another strand, if you wish.
Yeah, so it's good that you mentioned relativism, because I think the next topic that I wanted to start discussing was actually relativism, and there was something more to it, because okay, if someone actually you gave a pretty good description of relativism itself, but if someone still doesn't know what is relativism, so in simple words we can say that relativists think that there is no one objective truth. Correct me if I'm wrong. So if there is no one objective truth, but different groups can believe on different things, right?
Yeah,
And
they're all possible.
yeah, exactly. So it has some very, very, what should I say, unfortunate consequences. For example, there is a belief in many people that scientific truths are not absolute truths. They are not truth. They are just made up theories by scientists. And if you believe on something else, for example, we do have the law of gravity, for example, from Newton. But the relativists would say that you can believe on another law of gravity, and it's totally normal. Okay. And some people say that scientific theories are the theories which scientists have made in their own classrooms or in their own gatherings, and you don't have to believe on what they say. So am I correct? And if that is true, then how to deal with such kind of thinking? Can I start with Dr. Hoodbhoy on that? Because if some people start to say things like this, then don't you think that the whole enterprise of science will fall apart?
Yeah, just a quick and tandem,
Yeah.
like for Pervez as well. Like I was curious. So the thing that John described about relativism in the West, like we've seen it, it's influenced a lot of political thought as well, right? So you had the old, like in the old left wing, you had people like Noam Chomsky, like who were on the forefront, but then it shifted to people like Michel Foucault, and then you had influence of the Frankfurt School, people like Jürgen Habermas and stuff. So I was curious to know, is it the same in Pakistan as well? Like, do these people also have influence in Pakistan, like people like Foucault, Derrida, and others?
Yeah, because one more thing, that I have seen many young Pakistani students to believe on very nonsense things, and they just quote these kind of figures and some other philosophers as well as their argument. So that's why we are curious to know about that.
Well, I think we're going all over the place now. I don't think that one should introduce the idea of moral relativism in the same breath as one talks about objective reality. So let me come back to something that Jean just said. He said, is um, what we see around us just a depiction of reality, or is it reality itself? And does reality exist? Now, I can't answer that question, but I can say that I can have confidence that reality exists if I can predict the future course of events.
Mhm.
And so, for example, if I have, let's take classical mechanics, if I have Newton's laws of motion, well, then I can predict what a planet is going to be doing in the next 1 month, or the next 100 years, or the next 1,000 years. And if it is where it's supposed to be, then I have confidence that I have a grasp of reality without having to understand in its essence what reality is. I also want to address something else that Jean said. Is there a world out there, or is everything in your mind? Well, if I think about mathematics, if I think about, for example, just complex numbers, imaginary numbers, I have never, in my experience, and nobody in his experience, has actually seen a complex number or an imaginary number, simplified form. It's a creation of the human mind. I don't see any reason, I don't see any physical realization of that. It's simply the fact that we couldn't solve the equation x squared equals -1, and so had to invent something. It exists in people's minds only. And yes, we can transfer our knowledge onto computers, and maybe there is such a thing as universal human intelligence. This would be an argument for that. So, if something is transferable from one organism to another, from one person to another, from one species to another, from our species to what may someday be an artificially intelligent species, well, then I'll say that then it has absolute significance, but it's still a mystery how we came across it. So, Jean, how do you see this? Do you see our mathematical inventions, things like, okay, complex variables is one thing, but quaternions, the whole idea of groups, of rings, of fields, of all of these, which are our, our inventions, do they have a concrete existence? Do you believe in Plato's theory of forms?
Okay. Well, first of all, I was mentioning epistemic relativism, not moral relativism. I'm not a moral relativist either, but it's a different question than epistemic. And we're talking about, the role of epistemic relativism about religion. Now, it's true that I'm, in that sense, close to the logical empiricist, the logical positivist, that I want to separate mathematics and logic from talking about the real world. About Platonic view of mathematics, I don't want to discuss it too much, but I tend to be a realist about number, but not necessarily about sets. I do think that the Goldbach conjecture is either true or false, and that depends on properties of number, whether we know it or not, and even if we can never find out whether it's true or false. I think it's true or false because I have a strong intuition of what numbers are, and what Goldbach conjecture says about numbers is obviously true or false. But if you ask me about the continuum hypothesis, whether that's true or false, that I don't have any strong intuition about that, because that has to do with sets. And then in the end, it depends on definition of sets. The same way complex numbers depend on definition of complex number. The complex numbers, like real numbers, etc., are all constructed in the end from from rational numbers which come out of integers, etc. So these are, of course, construction. If you wish, I completely agree with that. The only issue to me about realism in mathematics is really whether you are realist about numbers, which I would be, and whether you are realist about sets, which I would not be. Okay, but that has nothing to do, for me, with the realism about the outside world. First of all, rather than discussing the movement of the motion of planet, I would start always from common sense realism, naive realism. Now I'm talking to the three of you by internet, etc., and I think I do that, and that's because you are there, okay? And I don't have to predict anything or something like that. I just see you, and I think because I have a good eyesight, at least at that level, I can see that you are there. And it seems to me that you have always to start from this naive realism rather than going to scientific realism, which is a more complicated issue. You see, all the idealists know that if they were born, that's because they came out of their mother womb or something like that, okay? And for that to be done, for producing a child, you need organs, and the organs has to be highly sophisticated and complicated in order to produce a child. And you don't have to know anything about evolution or anything like that to know that, okay? And that proves the existence of the outside world and the fact that it has a structure, and you can know something about the structure. Even primitive man, even people in the jungle know these things, okay? So I think we have to start always from the most basic sort of thing in order to refute idealism. Then we can go to scientific realism. Do forces exist? Does gravitation exist? Do the wave function exist? Do the curvature of space-time exist? Okay, these are more complicated topics which are, good for philosophers of science, but I always want to start from the basic views that there is a world out there. Whether there are human beings or not, there was a world out there when there were only dinosaurs, and there was a world out there when there was no life on Earth. It has nothing to do with us, the fact that there is a world out there which has properties. Moreover, we can know some properties of the world by direct observation. Moreover, our scientific theories give us more information. But what is true is that our scientific theories use, there's something. Anyway, something popped up here, but okay. Moreover, our scientific theories then use mathematical concept, and then of course you can ask question about the reality of the mathematical concept, in particular the reality of things which are mathematical, like the gravitational field or the curvature of space-time or God knows what, or the strings if you want, and reality. That's true. That's more complicated, but that doesn't. To me, it doesn't it just shows that when you go beyond common sense, but for example, biology can still be described almost entirely using common sense concept, and a lot of chemistry can be used too, unless you want to go to quantum chemistry. And then, of course, once you go to physics, you have all these mathematics, and then there are more subtle questions that can be asked, but we shouldn't start from that. We should start from, what I call common sense realism. And then, of course, we don't need any of this idealist stuff.
Okay. So since we are talking about mathematics, actually,
Okay, but things become
yeah, sure.
One goes to the microscopic world. So if you try and put an electron in a certain place, well, then you lose information about it. And we know that whenever you make a measurement on a quantum system, then that measurement causes the wave function to collapse. So you have you have then changed the state of the system by making a measurement. And so therefore, there's the famous question, is the moon there if you're not looking at it? Now, here there is, to my mind, since I am not.
Well, actually, he advocates another interpretation of quantum mechanics.
When Einstein asked that question to Pais, he wanted to make a reduction ad absurdum. He said, "Do you really believe the moon is not there when nobody looks?" He was reducing it to common sense realism. And of course the moon is there when nobody looks. And the moon was there before there were human beings. We know that. If we know something about the world, we know that. Okay? We shouldn't be wishy-washy about these things. Of course we know that. And it's a terrible thing. It's a terrible thing for physicists to
But if you use that common sense on quantum mechanics, then you shouldn't have double slit interference.
No, you do.
Common sense will not give you double slit interference.
Well, I'm going to.
Yeah, actually, he is an
my
advocate of
version,
Bohemian
my
mechanics.
version of the Quran. But
Okay.
Anyway, so I mean that's for Abdul. No, okay. Look, it's a whole quantum mechanics. That's there we're going to why I find quantum mechanics creating such a mess, because you see, well, there are various realist views of quantum mechanics. There is only one which I think is consistent, which is the de Broglie theory, but that theory does explain the double slit experiment without appealing to, and it does have the right predictions and everything, etc., without appealing to any idealist concept. But the point is that, you see, you have to get it straight, both with the Schrödinger cat and the moon. Einstein was bothered by the fact that everything is related to, our knowledge of the world, and then and everything's about information, etc. But forget about information, forget about knowledge, forget about human beings. The world is there whether they're human beings. He doesn't care. The universe doesn't care that we are here, okay? And our knowledge is a separate question. It's always very, very essential to distinguish, to use the terminology of my friend Sokal, but also of other philosophers, to distinguish between ontology and epistemology. Ontology is what exists, and epistemology is about what we can know or what we know. And these things are...
Yes, but how do you know the world is there if there's nobody to see it, is my question. It's an assumption then that it exists, irrespective of whether you are there or not. That, you must admit, Jean, is an assumption. It's an assumption that I'm happy to make, but do count it as an assumption.
Yeah, but I don't like this take assumption, because then people say, okay, let's assume that the world has 26 dimensions. This is a different kind of assumption. It seems to me that something so basic...
I think the world has actually 10 dimensions. 26 is only for bosons. But
yeah, exactly.
Yeah, but you see, the problem with that is that these are very different kind of assumptions.
Well, it's not an assumption, actually. It comes
so
out.
basic. You see, assumptions are things that you can doubt. But something so basic as saying there is a world out there, or the moon is there when nobody looks, seems to be so basic that I won't call it an assumption. But of course, you could say that, you see, there was this famous idea of Berkeley, which is solipsism. In fact, Berkeley thought there was something objective, God. But if you're a solipsist, you say, okay, it's all just my consciousness, then even if I assume that my hands is there, that's an assumption. I don't call it an assumption because it's so obvious, it's true. Okay, I believe I have hands, okay? And you too, and I believe I see you because you are there. These are not assumptions. But of course, you can call it an assumption because it could be an illusion. Maybe I'm dreaming, okay? Maybe I'm swimming in a swimming pool right now and I'm just dreaming, but I don't think so. You can always question everything. You see, if you call it, the word assumption should be used for things which are really doubtful. But if the most basic thing that glues together all our knowledge, there's a world out there and we can know it. Even animals know it. They don't know anything about quantum mechanics.
Okay. Look, I just wanted to provoke you with that, because it is frequently stated as an assumption. I think it's a reasonable assumption, but I will differ with you on that. I think it still needs to be put in the genre, in the category.
What's the alternative to that assumption? What's the alternative? That is all in your head? What's the alternative? Solipsism? Solipsism is an alternative, but that's the only alternative I see.
No, but if I move down to the microscopic world, it would be very dangerous to say that an electron is there. Yeah, it's I can't make that statement. I can't make it with certainty. I can give an amplitude or a probability for it, but I can't say it for sure that it's there.
Yeah, but the question I say, again, you go back to the issue of certainty and knowledge. I'm talking about what exists. Now, maybe electrons don't exist, but you see, the problem is that I was talking about the world of common sense, and the world of common sense has nothing to do with science. It has nothing to do with classical mechanics. You see, you are too much influenced by quantum philosophy, I'm afraid, that most physicists, namely, they always go into this sort of apparent indeterminacy of the microscopic world due to quantum mechanics, which I don't agree with, but that's even a separate question. I don't agree even about quantum mechanics. I think we can have a definite view of the world in quantum mechanics, and I explain it in that book and in many other books. But the point is that even if you forget about it, even if you take a primitive man, if you can still use this expression, doesn't know anything about science. I mean, most people in the world don't know anything about science. If you really, they don't think in terms of classical physics, and they don't say.
Yes, but I am afraid there are limits. There are limits on common sense. Look, Einstein came up with that famous paradox, the Einstein-Podolsky-Rosen paradox, and one shouldn't call it a paradox because it lies within the ambit of quantum mechanics. It's now something that anybody who studies quantum computing simply has to learn, and yet it's utterly bizarre and it's outside of common sense.
Yeah. But you see,
Sense.
Einstein also said that science is nothing but refinement of common sense. It seems to me that if you lose common sense, you see, the common sense tells you that at the end of an experiment, there is a definite result, for example, okay? Now, it seems to me that that's, of course, what you start from, what is your assumption, if you want, but it's not even an assumption because you just look at it and you see the result. If you drop, this is very essential because the problem is that it's true that science goes beyond common sense. I completely agree with that. But if you forget your common sense view of the world, if you deny it, or if you question it, if science leads you to question whether the moon is there when nobody looks, then of course you have lost everything, and then you are back to idealism. David Mermin, whom you probably know, has written that the moon is demonstrably not there when nobody looks. He has written that. It's nonsense. We have to say it's nonsense. It's a disaster. Because if you go and say to the religious people, science has shown that the moon is not there when nobody looks, then it's a huge avenue. It's a boulevard for every idealist and everything else. And you find these quotes, similar quotes in Bo Heisenberg and Pauli and Jordan and others. I mean, I've written them I've given them in my book. So I think it's very, very important to always start from common sense. See science as beyond, and of course contradicting in the conclusions what common sense would say. That's true. But the conclusion is one thing, and the general attitude with respect to the world is another one.
Okay, so look, I was trying to stay away from religion, but since you brought in religion, I feel that I must agree with you that anyone who claims that there was a virgin birth is then going against biology, therefore going against chemistry, therefore going against physics, therefore also going against common sense. So whatever the intricacies of quantum mechanics, and here I'll say that quantum mechanics defies common sense. There's no way that our common sense would have got us there. I think we're into a quibble, but we're basically on the same page.
Yes and no, because you see, the problem is that if you focus on quantum mechanics and then use it to question common sense about, let's say, the visible world, the macroscopic world, etc., then of course you run into a difficulty, because then, if you say the moon is not there when nobody looks, why not say that there's a virgin birth? I don't see what I mean, the problem is that is it an assumption to say that there is no virgin birth? You say, no, but it's based on biology, it's based on chemistry and so on. I completely agree. But if the outside world, the existence of the outside world is an assumption, then a fortiori, everything you know about science, biology, chemistry, and so on, so it's an assumption. It's even a more daring assumption, because again, somebody who doesn't know anything about science will still think that he had a mother and a father and so on and so forth, and that he needs his food and so on and so forth. There are all these common sense knowledge that people who are not educated in science at all will agree with. And of course, you can't, if you drop that, you say, well, but that's questionable because of quantum mechanics and so on, then of course you have to force your question biology, chemistry, and so on, and therefore we don't see why we should be against virgin birth or anybody, or the guy who went on his horse from one place to another, flying horse or whatever it is. That's a problem.
Yeah, but let me ask you this. If I say it is common sense that when an electron goes from point A to point B, or any body goes from point A to point B, it'll travel on a certain path now, later, and much later. But quantum mechanics says that sometimes it'll travel on that path, and sometimes it'll go to the moon and come back. Sometimes it'll go to the other end of the galaxy and come back. And that is not common sense. It's
But I see science goes.
if you were to tell an ordinary person that, he'd say, what nonsense are you talking? There's not common sense.
Yeah, but you see, wait a second, because there is, okay, that's why I was fighting against quantum mechanics all my life, against certain discourse about quantum mechanics all my life. You see, I mean, let's take things which don't lead to idealism so much. Let's take relativity, theory of relativity. And if you take the twin paradox, okay, the twin paradox are perfectly understandable on a realistic philosophy. But of course, it's against common sense. If you tell somebody, look, I travel and then I come back, I'm younger than my brother, my twin left on Earth, that makes no sense to common sense. I completely agree. But nevertheless, that's true, that's checkable, and blah, blah, blah. So, but there's nothing about, it's not this talk about observation. You see, once you bring in observation, why should bring you human beings in the most fundamental theory about physics? You know, human beings shouldn't simply not be there. That's the whole problem of the philosophy of quantum mechanics. But, okay, and that's why I say, but of course, if you say the electron may travel in different paths, but of course the problem, don't forget that the orthodoxy in quantum mechanics doesn't say that the electron may take one path or another. That's true in the Bricmont theory, that can take different paths. What the orthodoxy says that doesn't take any path at all, and on which it says that Feynman say that doesn't take any path at all, just at one point you detect it and you detect it at another point. And in between you're completely agnostic about what's going on. There is no trajectory because there is never any position. That's the orthodoxy. If you look really at quantum mechanics book, then you have the wave function, the Hilbert space, the observer, blah, blah, blah. But in the end of the day, the only connection to the real world is through prediction of statistics of results of measurements, nothing else. So it's a science that tells you what happens in the laboratory.
I agree with you on that. If you measure an observable and you can predict that observable, then you know you're onto something that is not wrong. I won't say it's right, because no theory of science is correct. Every reasonable theory of science is not incorrect.
What do you mean by, why, how could it be, if it's not incorrect, why is not the same thing as saying it's correct?
Well, what I mean is that you cannot. What I mean is that there can always be an experiment in principle which will disprove your theory of physics. And so here it is this is the principle of falsification. You always have to have an experiment that can be done which will falsify. Now, yes, I know you're shaking your head on that.
Another thing I don't agree with in philosophy of physics is Popper. I think Popper has been a disaster. Because you see, Popper very clearly says in the logic of scientific discovery that you can never justify induction. And again, this has a disastrous result, you see, because Hume said that, and then Popper says Hume is right, but I think they're both wrong. He says we have no reason to believe, of course, a theory, but we don't have reason to believe that the sun will rise tomorrow. Of course, we have reason. Well, there's no sun here, but unlike in Pakistan, probably, but it's like in England. But of course, the sun will rise tomorrow. And if we know anything, we know that. I mean, there are millions of things we know which have the same degree of certainty. Of course, they are never absolutely certain, for the simple reason that you could be mistaken, and you could be a brain in a vat, and you could be living in a matrix, and you could be this and that. You could invent all kinds of skeptical theories. But the problem is that to do science, you have to make, if you wish, assumptions. And I mean, of course, you make assumptions, but they're not of the same type. They're the assumption of common sense. And to the extent that the assumptions of common sense are correct, one of them is that the sun will rise tomorrow, and we have good evidence for that. And And we should rely on that evidence and make that inductive step, even though we can't prove it as we can prove things in mathematics. But I think it's very, very important to make a hierarchy in our degrees of knowledge and not always bring the uncertainties and the difficulties of quantum mechanics as the basis of science. A lot of science is ignores quantum mechanics. Most people, chemistry, biologists, certainly just take it for granted that there is somewhere a classical limit and we don't care about quantum mechanics. And even in quantum mechanics, that's my personal jihad, is that I even in quantum mechanics, I don't agree with the Copenhagen interpretation. But I want to go into that. Even not going into that, I think one should defend a realist view of science, a hierarchy of degrees of knowledge, and not adopt Popper's view, which is totally negative. I heard once a philosopher was, of course, postmodernist, and some postmodernists, even though Popper was not, like Popper, because he says, he said that you come up with a theory and you want to check if it's falsified, okay? And then it's not falsified, then, okay, you haven't learned anything because theories are always infinitely improbable, says Popper, and they always remain so no matter what. And of course, from a scientific point of view and the point of view of most scientists, if a theory is, passes a test, then it's confirmed. But that's something that Popper doesn't want to hear. He uses the word corroborated, but then it's not clear what it means. But, in the logic of scientific discovery, he doesn't want to hear about confirmation. Of course, it's confirmed. There's evidence for a theory when it passes a test. But for this philosopher, it was very good because then if you refute, if a theory does not pass the test, then you go back to square one and you start building a new theory, but you never learn anything. The whole point, of course, of the philosopher is to always say that science doesn't tell us anything objective, and then he was using Popper to that end. Popper did not mean to do that, but in the end he did. There's a philosopher, an Australian philosopher of science whom I like, David Stove, who wrote a book called Four Modern Irrationalists, Popper, Lakatos, Kuhn, and Feyerabend. And it may strike you to have Popper included in that, but Popper is included in that because of his absolute and complete rejection of induction. And induction is some inductive reasoning is at the basis of the whole of science, and we can't escape that.
Well, I would like to keep an open mind on that because I do think that in physics, at least falsifiability does have some value. I don't think it has value in, let's say, biology. There's no one thing that you could find which would demolish or confirm evolution. So, but in physics, let's say that string theory makes a very particular prediction. Then, if that prediction is not confirmed, then we could say that that string theory or that version of string theory is incorrect. So it does not seem to be totally without value.
Of course,
and while I generally tend to agree with you that the world can be objectively described, that our minds are capable of uncovering the laws of physics and of making the world understandable. Yet, when I come to quantum mechanics, and so let me come back to Feynman's path integral. There are an infinite number of possibilities, and the world proceeds on an infinite number of trajectories, and yet it is just the smallness of H bar that we actually see the classical world as we see it. So I'm still going to keep an open mind on that.
Look, I'm sorry if I have to bring in this picture, but here is a simulation of trajectories in the de Broglie-Bohm theory. I can put it back if you wish. And there's only one trajectory. You can perfectly have a theory where each particle has a position at all time, and it has only one trajectory. There's a set of trajectories, and depending on random initial condition, you can have different trajectories for different realization of the same experiment. But you see, the Feynman path integral is extremely misleading because number one, maybe not important, but number one doesn't make any sense mathematically. It's not a well-defined object. It's not a measure. It's not a complex measure. It's just a formal it's a mnemotechnic trick, like the Feynman diagrams, by the way, which are allowing you to remember, to sort of write formally the solution of Schrödinger's equation. But it's equivalent to Schrödinger's equation. There is no path. People say, oh, it takes all the paths. There's no reason to believe that. There is no evidence for that. We've never found an electron in two places at the same time. And it's only because then you introduce the collapse rule. But the problem with the collapse rule is that it's direct contradiction with Schrödinger's equation, including Schrödinger equation applied to the measuring device. So why not admit that there is a problem rather than saying everything is okay? I think there is a problem and I think there is a solution. But if you don't agree with my solution, you should admit that there is a problem, and a problem within physics rather than drawing philosophical conclusions, which I think are misleading, from physics. There is a real drawback. There is a real drawback in ordinary quantum mechanics. It works perfectly well, and my view is that it works perfectly well because the de Broglie theory underlines it. But if you don't agree with that, one should admit that there is simply a serious defect between the contradiction between Schrödinger's equation and the collapse rule.
One minute, Dr. Hoodbhoy. Can I just say one thing before you respond to this? So for the listeners, I just want to tell that Dr. Bricmont is actually an advocate of something known as a particular interpretation of quantum mechanics, which is known as the Deuteron Theory, which is actually a kind of like a hidden variable theory for quantum mechanics. And in that particular theory, we do have definite trajectories for particles. But there is one question that I would want to ask, and then Dr. Hoodbhoy can respond, and Dr. Bricmont can respond to it. That one of the biggest problems of this particular interpretation of quantum mechanics is that we don't know how to make quantum field theories out of this particular interpretation without violating Lorentz invariance. So how do we do that?
Well,
without violating Lorentz?
The problem is that
let me come back to what Jean said about path integrals.
Yeah.
Every self-respecting quantum field theorist now starts with the path integral. He doesn't go to the functional Schrödinger equation. The functional Schrödinger equation requires you to make a particular gauge choice. So I'm becoming a little technical, sorry, but you can't write down the functional Schrödinger equation without putting a constraint on the states. Whereas with the Feynman path integral, you don't have to worry about quantum mechanics. It's all there in the smallness of h bar. It's a perfectly well-defined procedure. Yes, I have heard you that you say that the measure is undefined, that the measure is infinite. Well, it's infinite, but upon discretization, it becomes finite. And so that's not a problem. If you take a box and you quantize, it's fine. I don't have a problem over there.
Oh, the function and integral doesn't make sense even for one particle as a mathematical object. It's not well defined, but that's okay. I mean, it's just equivalent to a Schrödinger equation. But you see, now I'm afraid that we are going to get too technical. So, and maybe you want to go back to more general question about,
yeah, I think so.
But I want to answer
on hidden variables then. On hidden variables. So doesn't Bell's theorem rule them out?
No. But you see, now we have to go into a whole. We need a whole seminar on that because it's not true. It's not true. You see, you can read Bell. Read the book by Bell. I read the book by Bell when I got it back in the 80s or something. I read it in one afternoon. I read it without lifting my eyes because at every page, or not every page, but almost everywhere, he defends the Broglie theory, which is a hidden variable theory. And is universally granted to having refuted hidden variable theories. So there is something wrong with it. Okay, there is something deeply wrong in the way we teach quantum mechanics to students, because we tell them that there's this man who has refuted or showed something wrong with the hidden variable, and then when you read him, you see he defends that theory all the time. So I mean, maybe he's crazy, but that's not what people say. People say he's crazy. I mean, I had a professor who basically says he's schizophrenic. But he's schizophrenic because he had read his book. But people don't read his book, don't read any of his papers. And every paper he does defend the Broglie theory. And there is something deep. I want to convince you that there are deep problems with the ordinary discourse about quantum mechanics. But I can briefly maybe reply to your question about quantum.
Yes, but okay, now I want to know from you. would you, in teaching quantum mechanics, how different would that be as compared to, let's say, a typical book like maybe Griffiths, where you start out with saying, okay, there's a Hilbert space, there's a vector in that Hilbert space,
You mean
when
Robert Griffiths?
et cetera, all those standard assumptions of quantum mechanics. In your way of looking at quantum mechanics, what is the difference between that and the standard?
If I can just interfere for a second. So Jan, Pervez is talking about David Griffiths, not the Griffiths you're
Not
thinking.
Robert Griffiths, okay.
No. Right.
Yeah, I don't know that book, but I did teach quantum mechanics in another university, but for mathematician, and I use a work by Shankar, I think.
Yeah, that's good. I know that book as well. Yeah. Okay, so that's just good enough.
Yeah, that time I was not as as much an apostate as I am now, but I was sort of skeptical. But I don't know if I would teach things very differently, but I would not repeat what is usually said about the Copenhagen interpretation being the only one, and Bell having refuted hidden variable, and so on and so forth. Either I wouldn't say anything about that, or I would tell things differently. In my book, I say that we should tell students three things. One is that there are problems, explain non-locality and Bell correctly, and then thirdly, if people want, explain the Bricmont. I don't want to start with that. I agree, but to me, it seems to me that you should, explain that the theory in the end predicts results of measurement and doesn't tell you anything about the world, and that's exactly what the problem is, and why the result is idealist stuff that comes in. But to reply to your question, you say about Lorentz invariant and so on, in the early papers by Bohm, which nobody reads again, it does give a quantum field theory. It does give a quantum field theory. And the quantum field theory that you have is predicting, since we're all about predictions, then these predictions are Lorentz invariant. I can't explain it why, because it gets technical, but you do make the correct prediction about the Michelson-Morley experiment. And that's also explained by Bell, by the way. But you have to be one has to be a little bit subtle about what one means by Lorentz invariant. It's a complicated notion, actually. It's not such a simple notion. But if you're only worried about predictions, then you get the right prediction. Therefore, they are so-called Lorentz invariant. But you see, there are millions of problems with quantum field theory, which I don't want to go into because our listener will be lost. But about the fact that it's very formal, the fact that it describes the outside world even less, because in the end it describes scattering's cross-section and so on, predicts them correctly and so on, which is remarkable, but it doesn't really, and it seems to me there is again something epistemologically wrong. That all the discussion during the Solvay Congress, the discussion between Bohr and Einstein and so on, the discussion with Schrödinger's cat, and even Bell's theorem, and all these things, and the Bricmont, were in the context of non-relativistic quantum mechanics, non-quantum field theory quantum mechanics, particle quantum mechanics, okay? Now comes some idiot like me who says, look, all your problems are solved. And people don't listen to what the idiot says. He jumps on the idiot and says, but what do you do with Lorentz invariance? What do you do with quantum field theory? That's a universal reaction. So it means that we're not interested in having an answer to the problem because we don't think there are problems. You just want to shut the idiot, okay? So it's like if I have some miracles from the Quran and I refute some miracles and I refute that, yeah, but what do you do about those other miracles? Okay, let's deal one thing at a time. If things can be completely clarified within non-relativistic quantum mechanics, then we'll be interested in quantum field theory and relativistic quantum mechanics later. But let's see if you concede that the problems are solved. If you don't, then of course we are back to square one. But it seems to me that there is a desire. There is a very, I think there is something really sick in our profession, and which I've always fought against, which is the refusal to accept that there are problems with quantum mechanics, ordinary Copenhagen quantum mechanics, refusal to discuss them, and in general, then taking the attitude, shut up and calculate, which I've been, of course, taught when I was a student, I was taught later, and had very, very difficult relations with my colleagues, some of my colleagues, because I was questioning, it is really a religious attitude. The Copenhagen, Now it's relaxing, and younger people are more eager to listen, except Abdul, of course. But okay, I'm teasing you. But there's more openness. But in my generation, the generation 10 years older than me, it was absolutely like a religion. It was unbelievable.
Well,
because of the refusal to discuss.
The questions are now much more sophisticated also. So what does quantum mechanics look like in the neighborhood of a black hole? We know there are black holes. We know that general coordinate invariance is fundamental. We know that we can't marry the two with each other in a mathematically consistent way because of renormalization problems. Common sense has abandoned us. When you take the issue of whether information is destroyed in a black hole or not, I'm sorry, common sense provides absolutely no help over there.
Of course, but I don't know. I don't even know what information means.
It is only a matter of what is mathematically consistent, and we lose our understanding of reality beyond what the mathematics can offer to us.
Yeah, but you understand. You see, you're really having all the reactions which I object to, in that sense that I think you have to start with the simplest thing about quantum mechanics and ask whether we understand them rather than jumping to black hole, general relativity, and so on. And I claim we have problem understanding the Stern-Gerlach experiment, the double slit experiment, the EPR Bell experiment, so on and so forth. Let's try to understand these things first and then ask the other questions. But since people think they've understood those, you see my disagreement with the majority of physicists, that physicists think, well, we have understood that we have only problem with general relativity and blah, blah, blah. And it's because they agree to work in a very formal way and not ask themselves, yeah, but what does it mean about the world? What's there in the world? Is there anything in the world? And that's where you get into this idealistic stuff, because you don't ask those questions. And when the question are asked, you give idealistic answers, saying, oh, it's all about information and so on and so on. The world is not about information.
One cannot spend all one's time upon what's happening in the double slit experiment. There are maybe many different ways to explain that, maybe many different ways of understanding entanglement and how states ultimately disentangle and so forth. All that is there. But look, there are many more fundamental questions. And those fundamental questions will perhaps give us a real understanding of what quantum mechanics ultimately is. And maybe that might lie in the domain of quantum field theory rather than particle mechanics.
Well,
okay, so
I think we've exhausted
it.
Yeah, I think we've exhausted this topic. I didn't want the whole thing to be purely about quantum mechanics.
Yeah, exactly.
But just for clarification's sake, Jean, would you say it's Bell's work? Would it be nice to make a distinction that he showed that local hidden variables aren't there, but non-local hidden variable theories still hold, like from his Bell's theorem? Like just a quick clarification though, because I do want to move on to one more topic.
No, I don't agree. He said that. You see, EPR, as I understand it, showed that there is a following dilemma. Either they are what you call hidden variables, or their actions at a distance. So the or would mean the world is non-local. And what Bell shows that those hidden variables that EPR postulated in order to avoid non-locality, in order to save locality, those hidden variables are not there. But Bohm theory is a hidden variable theory that does not include those hidden variables. Its other hidden variable is positions. And that's the paradox. That's where it gets subtle, because you can introduce positions and indirectly velocities, but you have to understand what measurements means in Bohm's theory. And measurements, of course, is not something which you naively think you measure something pre-existing. And it's a measurement, it's an interaction between a measuring device and a particle position. So once you understand that, and a trajectory, let's say, once you understand that, then of course the whole centrality of measurement disappears. There's, of course, the world is subjective and deterministic and all you want, because there are trajectories or fields, if you wish, trajectories of field in field theory. But then you have, then of course the hidden variable that EPR postulated are not there, and therefore non-localities. Therefore there are actions at a distance. That's what Bell proves. That's what he keeps on saying.
Okay.
He may be wrong. He may be wrong, but you see what is irritating with Bell is that he's credited for having shown something which he constantly denies. That's
good.
That is refuted local hidden variable theories. He does say that locality. You see, the hidden variables is not an assumption. Therefore, it's not. It's a consequence of locality. So if you refute the hidden variable that EPR postulated, you refute locality. That's what he says. He doesn't say that there is a sense in which there is non-local hidden. Of course, the Breuil-Bohm theory is a hidden variable which is non-local, but it's non-local because the world is non-local. Quantum mechanics is non-local. Reduction of the wave function is non-local in quantum mechanics. But there, of course, then people are wishy-washy about the wave function means, what reduction means, and it's not clear what it means. And of course, they say, well, maybe it's local after all, etc.
Right. Well, it's a good thing we have many worlds, and you can get around Bell inequalities. But that's for another time. I wanted to move on to another discussion, like in a completely different direction.